Alright, so this lecture is going to cover I/O ports, such as serial IEEE 1394, USB, parallel, and maybe a couple others. We'll see how long the recording goes. So, let's start with the oldest technology, one of the oldest technologies, and that would be our serial technology. Now, this is commonly referred to as COM and uses the RS-232 standard. And this is our 9-pin DB cable that we are used to seeing on the older technologies. And most computers nowadays don't even come with this, but you have some options if yours doesn't and you find that you need one. Previously, this was used to connect modems. Mice were connected via serial. Plotters, printers. You would connect up your PDA, if you remember PDAs, personal digital assistants. Digital cameras. You can use it for PC to PC connections. It transmits 1 bit of data at a time, but it is full duplex. So that's excellent. It's also considered a reliable technology. It ranges in speed from 300 bits per second up to 115,200 bits per second, and that's the highest transfer rate that you can get within Windows. It uses 7 or 8-bit packets, offers flow control options and parity options, because once again it is a reliable delivery. You can't daisy chain serial, so it's point to point. And I have pictures up here of the DB9 connection, but they also had a 25-pin connection that looked very similar to this, but had 25 pins. It also looked very similar to the parallel connector, but one's male and one's female. Now you can enable and disable your serial from your BIOS as long as you have it available on your motherboard. And like I said, nowadays it's becoming less common for computers to even have serial connection. So what do we still use serial for? Well, you need to console into a router. We do that all the time in our routing class. And if you need to console into a router, we have cables like this. So you have one end that plugs into the console port on the router, and the other end that plugs into your computer. What do you do if you do not have a serial port on your computer? I have solutions. You can get converters. So you can have one end has a USB connector, so you plug that into the USB, and then the other end plugs becomes a serial port for you. And then you would plug this cable into this end, and that converts it to serial. And then you can go ahead and use your console connection software in order to do the connection. Another older technology that I didn't even pull up any pictures for was parallel. Most commonly with parallel we're doing LPT, which is line printing, so using it as a printer connection port. But how are most of our printers connected these days? Via USB. We really don't see the parallel ports anymore, and once again this is something that's been deprecated on motherboards, and we're not seeing parallel ports very often. The parallel port used a DB25 connector, so it actually looked very similar to this connector, but it was 25 pins, 2 rows, 25 pins instead of 9. Parallel does support daisy chaining though, and the printing standard you may want to be familiar with is IEEE 1284, and you probably should remember that because it's likely that that might come up. And that's the parallel printing standard. It's a standard that identifies all the rules for parallel printing, the speeds and cable lengths, and you know how the printers send the data. And I think as long as you know the standards, you'll be fine. So the next technology that we're going to get into that we actually use is going to be USB. Okay, so this one is extremely popular. You see USB all the time. USB has practically taken over the world, and we love that. Universal Serial Bus, and it is used to connect just about anything, hence the universal part. We have several different speeds associated with USB. So I have a document here to show you, and this has the table of USB revisions and speeds. So 1.0 came out in, I believe it was the early to mid 90s, and it's 1.5 megabits per second. It's considered low speed, 3-meter cable length. It was not very heavily adopted at all. You really didn't see USB until 1.1 came out, and really the reason behind that was there's a lot of bugs in it. So after they fixed a lot of the bugs, they pushed 1.1, and that's what most people are familiar with. 1.1 operated at 12 megabits per second. It's called full speed, and also offered 3-meter cable lengths. Then USB 2.0 came out, and that offered us 480 megabits per second, which translates to about 60 megabytes a second, but actual throughput is right around 35. With 2.0, you can get up to 5-meter cable length, and it's called high speed. And then we have 3.0, which I'll talk about in a moment. But first, let's focus on the other two. And generally, what can we do with USB? So we have a couple different connector types. We have type A connectors and we have type B connectors. And traditionally, one end will be type A and the other end will be type B. Now this particular cable right here should look fairly familiar. This is what you would use to connect a printer. This end goes to the computer, this end goes into the printer. This is also what you would use to hook up your monitor if you had a USB hub on your monitor. This end would go in the monitor, this end into your computer. USB allows you, each USB root hub, and I'll talk more about this in a second, can handle 127 devices. USB supports daisy chaining. So through the act of daisy chaining hubs, and if I remember correctly, you can only daisy chain up to 5 hubs. The other thing is that USB is bus powered. USB devices can also be self-powered, so they have a power adapter that goes with them, or they can draw all of their power off of the bus. And for bus-powered devices under USB 1.1 and 2.0, each port offers 500 milliamps of power. Now once we get to USB 3.0, we get 900 milliamps of power. It supports hot swapping, so you have the ability to go down into your lower right hand corner and click the eject devices button and shut the device off and pull it out. And in many instances with your USB devices, you can just disconnect them. You don't even have to officially disable them. So you have hot swapping, you have daisy chaining, and those are the best parts of USB. But now we have USB 3.0. So you can see we have the two different receptacles, and notice USB 3.0 is indicated by blue. And there is a very specific reason for this. There's a couple of reasons for this. One is the actual physical makeup of the 3.0 connector. The 3.0 connector is slightly longer, so the port is deeper. So when you plug a 2.0 device, it is backwards compatible. If you plug the 2.0 device into the 3.0 receptacle, it doesn't quite get to the end, and so sometimes the connection isn't made very well, and if the device isn't exactly the right, or the plug isn't exactly the right angle, you'll get situations where it connects and disconnects, and that is somewhat obnoxious. So 3.0, pull this back over here, operates at 5 gigabits per second. It's known as super speed. And cable length is back down to 3 meters. And the reason for that is because you're pushing so much more data over the wires. And so they had to lower the cable length in order to keep from having attenuation problems. Attenuation is weakening of the signal. So the other thing I want to show you about USB is the host controllers and how they work. Because while you can plug a 2.0 device into 3.0 and it is backwards compatible, it will read the device, and you can plug a 3.0 device into a 2.0 and it will read the device as well, but they work a little bit differently. First of all, USB 1.1 and 2.0, even though they're serial, and we know, serial is full duplex capable, USB has been half duplex all of this time. And you have these host controllers, and the host controllers control how the data is sent, and it chooses to send the data in half duplex. Now, this is the architecture of how this works on your board. So for 2.0 and 1.1, you have 2 separate host controllers to deal with the 2 separate technologies, but then you have a root hub that is shared by these host controllers, and then these would be the ports in your computer. And basically, if I plugged a 1.1 device into this port, then it would operate at 1.1. If I plugged a 2.0 device into this port, it will operate at 2.0. Now, with the 3.0 host controller, the root hub doesn't share with this, because this is actually a full duplex technology now, which is excellent. So it's managed a little bit different. This other one with the half duplex, it's actually called a master-slave technology. The host controller is the master, device is the slave, so the master is controlling how data transmission happens. With 3.0, it's more of a bus mastering situation, and the host controller still provides host control, but everything can run in full duplex. There's controllers at both ends. So you have a separate root hub for 3.0. So these devices are specifically 3.0. All right, so what technology competes with USB? Well, that would be FireWire. And FireWire was developed by Apple. They're extremely proud of it. It is also referred to as its standard name, which is IEEE 1394. So IEEE 1394. This is also a serial technology. It's a high-speed bidirectional serial transmission. It allows you to do the null modem thing, which is connecting 2 PCs together, connecting digital devices. It was commonly used to connect video cameras. That was really popular, and the reason for that is that FireWire, or IEEE 1394, is really good at isochronous transfers. So an isochronous transfer provides essentially a steady stream of data. It doesn't check, it's not reliable. It doesn't check to make sure that the packets were got to the end that they were trying to get to, but it sends the packets in order. So this is great for streaming video and streaming sound. And it's fast. So 1394A was our first one, and 1394A transferred at 400 megabits per second. You have a 4 and a 6 pin variety of connectors. And then we had 1394B. This transferred at 800 megabits per second, and then these all use 9 pin. You have 10 meters in length. You only have 4.5 over here on A. And then the newest varieties, which have been directly competing or trying to directly compete with USB 3.0, are S1600 and S3200. And S3200 is the newest. And you can see this is 1.6 gigabits per second and 3.2 gigabits per second, which still is not as fast as USB 3.0. So it's sort of falling by the wayside. The other technology that's taking it over is Thunderbolt, which I'm not going to really get into right now. So other benefits of FireWire: hot swapping, daisy chaining. You can have up to 63 devices on a bus. And if you don't have it in your computer, you can buy add-on cards that do that. Same thing with USB. You need more USB ports. You can buy an expansion card that you can connect via PCI or PCI Express, and give yourself more of these ports if you need them. These are the connectors that you'll see. These are commonly the connectors. So this is the 4-pin. FireWire also goes by the name of iLink. So this is Sony's version of it, is iLink. Because 1394, IEEE 1394 is an open standard. It's Apple coined the term FireWire. And so this is an iLink connection, but it's the same thing. And then this is the 6-pin version. So this is a 4-pin version, this is a 6-pin version. This is what you would commonly see on laptops. This is commonly what you see on desktops. And then these are the other different types of connectors. Alright, so a couple other things that get an honorable mention. Your PS2 ports, these are used for connecting mice and keyboards. So purple is keyboard, green is mouse. PS2 is not hot swappable. That's one of the most important things you can know about PS2, is not hot swappable. If you unplug the device, you will not get functionality back unless you restart the computer, and that's what I want you to take away with that. They're uncommon now. You don't see them as much anymore. Most computers don't even come with PS2. Audio. 1/8 inch or 3.5 millimeter jacks are the most common for speakers, headsets, mic, line-in. Know the colors. Mic is generally pink, line-in is generally blue, and green is going to be your speaker or stereo. If you have more stereo options, you'll see brown for left to right speaker, orange for the sub. And then the other audio option you need to be aware of is SPDIF, Sony Philips Digital Interconnect. This is digital audio. It's fiber optic audio. And these were extremely popular on DVD players for quite a long time, and you still see them on sound cards. Let's see, so mice and keyboards, commonly USB, but used to be PS2. And KVM, what is a KVM? Keyboard, video, and mouse. This is essentially a switch, and we all have these under our desks in the classroom. They come in a couple of varieties. You can have USB, you can have PS2. Ours are USB. They can be powered or bus powered. The powered ones tend to be a little bit better and more reliable. And KVMs allow you to have one keyboard, one mouse, and one monitor, and control 2 or more computers using those single set of devices. And it's just a little switch. You'll either have a keyboard shortcut like Control, or Control insert. There'll be some sort of keyboard shortcut that will allow you to switch between them, or it will have a physical button on it. And your KVM ports have both, and you should play with those and take a look at them. But know what KVM is. Alright, I think that about does it for our I/O ports. Next up will probably be partitioning.